Hi guys, and it's design time again, as same as in the last few episodes. This time something a little bit different, a passive design. It means there are no active components on it. As I showed you before, I planned to make a reference based on the FAE rubidium frequency standard that delivers a 10 megahertz configurable via the serial port 10 megahertz sine wave. The problem is that the sine wave has a lot of harmonics, or too many harmonics that I do not like. So came out with a design. It's called a crystal lateral filter. It is I use 4 stages, I mean 4 crystals, as you see here. There are a lot of calculators online and a lot of description. I will leave some links in the description of the video, but this is what came out. This is one of the 2 boards I designed. This is a breakout and test jig or board, or however you want to call it. Yeah, that means that whatever comes out from the calculations, I will put here, the solder here, and try it out with a spectrum analyzer. This thing is quite old, you see, 2020. But I touched this project again with a reference, with a rubidium reference. This is why I took that again in my hands. Yeah. The breakout boards, in and out is SMA. It's lightly terminated AC with a 1K resistor. The 1K resistor, and I mean AC because it's in serial with a capacitor. Here you can test the standard HC series, HC49 series, I think it's 49S, SMD series crystals. But you can test quartz filters like FM-IF filters for 10.7 megahertz that have these 3 pins. You just have to jumper the in and out differently. In this ladder filter, it is, if you use these larger crystals, the attenuation is, yeah, more or less okay. But I designed something different too. I designed this thing. This thing is exactly the same what you see on the big board, but with 2.5 by 3 millimeter small SMD crystals and 04 or 2 capacitors. This is really small. The idea was to make it at the size of a standard HC49 crystal. And here you have an HC49 crystal compared to the board I made. You see it is, yeah, it's not much bigger and thinner. The only negative thing is that you have a lot of attenuation because of the SMD crystals here. Probably if you use more selected one or better ones, it will be much better. But anyway, this is planned. If this gets in use, at the end of it, at the output of it, it will be an amplifier to compensate the losses of it. To see how small the whole thing is. This is the PCB for that. just for fun, I let the vias open. That means not tented. Normally I'm doing only tented vias because it makes it easier to solder if it is so near everything, it's so small everything. But the Gerber files, the new ones, have tented vias, but it looks much better like that. You can mount this thing either vertically, like that, or you can mount it horizontally. It means the pins showing down, and then you have a center pin that goes to ground. That is just for additional mechanical stability. So this is, let's try to test the thing on a spectrum analyzer. By the way, guys, if you like my videos, if you like the content of my videos, please press the like button and subscribe. This helps the channel to grow and to show you many more things that I have done in the past and I plan for the future. Okay, let's try to test the whole thing. Okay, this is the setup. Here I have the reference. The output goes directly to the board. And now, for now, I've connected the spectrum analyzer. This is the beast that is so loud behind me, that makes so much noise. I have it connected directly before of the filter to see how the output looks, or the output of the reference of the standard, the rubidium standard looks without the crystal ladder filter. So this is how it looks. We have 4.8.9 dBm, and here you see first, second, third, fourth, blah blah blah, the harmonics. They are not very high, but they are there, and we want them gone. So now it's connected at the output of the filter. For now, I'm using the bigger ones, the HC style 1 filters that are on the board, on the breakout. And you already see that all the harmonics are gone. The bad thing is that we lost a lot of signal. This is because the crystals are not matched at all. The input and output is not matched. It was just a proof of concept to see what is the worst case, really worst case of signal that I can lose, and if I could tolerate that. And for me it is not a problem. It is 10 dB, we lost 10 dB more or less. This can be easily compensated with an amplifier at the output, and it's, so either better matching or correct matching of the crystals and in and out, or something between, and even so the amplifier will be at the output of this filter on the designer plan. So now let's take a look on the small board with the SMD crystals. The board with the SMD crystals is now on the test jig. I changed the pins, and we see that now we are losing 15, almost 20 dB. Yeah, almost 20 dB we have lost. Anyway, it is a feasible way with an amplifier after that. This thing is very stable. And again, the crystals, the SMD crystals, are not intended for these things, yeah? So, if we choose better crystals, the result will be much better. And for now, the PCB is made to use all this kind of crystals. So if you use crystals that are 2.5 millimeters by 3 millimeters with the same in the same package, then you can use it on this mini board too. There are a lot of calculators. I will show you a few of them now. So the most prominent one is called Xtals, Crystal Data Filter Calculator. The latest version, the last version I know is 2.0.5.2. This is a very comprehensive program, software that you can put a lot of input on it and tweak it a lot. There's a help file in German and in English. I will put links in the description where you can download it. This is the one that I'm using that is installed on my PC, either as an installer or as a portable. That means it's a zip file, you just unzip it and you don't have to install anything. And there are some other ones, online calculators that I will put in the links in the description too. This is one of the online calculators. That's from this guy, Giangrandi. He has a lot of information about narrow bandpass crystal ladder filters. And if you go down, then you have the calculator. It is not comparable to the Xtals that I showed you before, but it's completely usable. Here you have some examples. Another one is from Chang Puak. I don't know if I pronounced that correctly. There are a lot of calculators and a lot of interesting stuff on this page. This is a much more simpler calculator, but still usable again. So that means for now this is the setup again, the output of the FAE reference, rubidium reference, going through the filter. This is how the bare PCB looks. Of course, Gerber files and design files are available on request. And the output again of the filter. The only bad thing is, for the SMD type of filter, we lose a lot of signals, but can be compensated with a Post Amplifier. Okay guys, thank you for watching. Please press the like button if you like what you see, and subscribe to my channel. Thank you. Cheers.